What's up everyone, welcome back to my channel. So as the first video of this new year 2023, I made up a problem that actually was kind of like mimicking from one of the old Putnam problems in 2000, I believe 2028 is one of the old Putnam tests that I've taken back then. And again, if you were thinking of taking Putnam exam, I would say that usually they will put the first problem as the easiest, and usually when they decide to make the easiest problem, they will choose number theory because they won't use any deep idea from number theory. And of course, it means that even if you have never taken the course, you should be able to use a lot of basic number sense to solve the problems. Or perhaps you might find a difficulty that there is something that is not easy to explain that clearly, but it's definitely the easiest because it's the most logical and also require the least knowledge to solve the such kind of problems or for that topic. So anyway, if you have already saw one of my old videos that I made, you actually found out that the problem looks very similar. And in fact, the original problem says 1 over a plus 1 over b is equal to 3 over. Usually they would just put the year of the exam, which was 2018, but since this is the year of 2023, I decided to change the denominator to 2023. Now, of course, one thing that we need to talk about is, as number theory problem, we usually like to solve the variables, in this case a and b, as integers. And in fact, we would like to stay as positive integers because usually it will be a lot easier if we just limit down our range into just positive integers, or I would like to call it natural numbers. And if we actually include the negative values, we might actually end up with kind of a mess too. And things will actually get a little bit ugly if we are trying to consider factoring out. And again, for number theory problems, especially something that is very basic or not much knowledge required, factoring is always a good idea and very useful. So we actually need to have a hint here, which says 2023 is actually have the unique prime factorization 7 times 17 squared, and we actually see why we need it later. So again, we want to solve all the possible values a and b that satisfy the equation up here. And again, we can actually see that a and b are actually kind of playing the same role because the fractions are actually kind of symmetric. We have 1 over a and 1 over b, and the numerator are actually the numerator is actually the same. So we can actually see that when we find one pair of solution, we will be able to find the other pair immediately by switching the values of a and b. Okay, and in this case, I will not try to figure out the actual value. I'll just leave it as a product of prime factors or something like that, and I'll leave you guys as an assignment to find out the actual values of those solutions. So here we go. How are we supposed to solve it? Well, first, since we are trying to do it as a number theory way, we don't want to see any fractions, of course. So the best way to do it is multiply by the common denominator. So we need to multiply by 2023 times AB. Then we'll be able to get, and I'll bring the right hand side to the left and multiply by -1 so that we will have positive leading coefficients 3 times AB. And now keep in mind, we multiply everything by the negative version of it. So we will actually get 2023 times here will give us B, and the other one will give us A. So in fact, we will just get 2023 times the quantity a plus b. And then since we bring everything to one side, the other side is of course being 0 now. Then for this kind of problem, the best way to do it is, since we want to get everything symmetric, because a and b are actually playing the same role, they are like having a symmetry. So in order to split the 3, which is not a nice term, and to both a and b, we would like to multiply something such that the coefficients will become a perfect square. So as 3 being a prime number, we will just multiply another 3, so that now we will get 9ab minus 3 times 2023 times the quantity a plus b. Then we're going to add something on both sides of the equation, because again, as number theory problem, we would like to factor out at the end. And what should we add here? So let's take a look. Since we were saying that we want to split the 9ab into something a times something b, and we want the leading coefficients be the same, in this case we will split the 9 into 3 times 3, so that we will get 3a times 3b. And we will actually see that a and b are just 2 dummy variables, and they're symmetric because and they will just play the same role. So if we are trying to do that, now in order to cancel out the middle term here, we will need to think what we should put on the constant term for each factor. And the best way to do it is of course putting them having the same coefficients or constant terms, so that we will see that each factor is actually similar to another factor when we try to split the equation. So again, that's because we want to have the 2 factors look almost identical, so that they will play the same role and it will give us a symmetry. So to do that, let's see. We have 3a here times 3b. So we're going to do the cross multiply and see how we are going to get negative 3 times 2023 times a plus b. So it's actually very clear. If we distribute the 3 inside, we will actually have 3a plus 3b already. So in order to get the negative 2023, we just need to put negative 2023 here for both top and bottom, and do cross multiplying. We'll be able to get the middle term. And therefore, we actually need the constant terms in each factor be negative 2023. So if this is what we're trying to add together or put together, if we multiply back, we actually need to have the constant term being 2023 squared in order to factor out into what we want. But as we add something on the left-hand side of the equation, we need to do the same thing on the right-hand side of the equation. And therefore, now the right-hand side becomes 2023 squared instead of 0. Good. So now we figure out what the left-hand side of the equation becomes already. For the right-hand side, we're now going to use the hints that we have on the board, because now we need to factor out this value here. But again, we have already seen that 2023 is 7 times 17 squared. So if we square this, we will actually get doubles of the copies. So we have 2 copies of 7 times 4 copies of 17. Excellent. So what does that do? Now, as we see that each factor actually looks almost identical, we just need to pick one of them, and then we'll be able to get the other one immediately once we solve one of the factors. How do we do it? Well, let's say if we pick the first one. Again, it doesn't really matter. If we look at the first one, what can we tell from the first factor, 3a minus 2023? Well, Here's the deal. We can try to use modular arithmetic to help us, meaning that we're now going to think of the remainder of this factor after we divide by some specific value. And in this case, what can we choose? We can actually choose to divide by 3 because, as we know, a being an integer, 3a must be a multiple of 3. So now if we try to divide by 3, we can actually see that this factor is congruent to 2 mod 3. In other words, the remainder will be equal to 2 after we divide this factor by 3. So it also means that for the other term, the factor will be congruent to 2 mod 3. So in this case, we see that if we try to split the right hand side into 2 parts, each part has to be a product that's congruent to 2 mod 3. In other words, now we need to consider the possible cases on the right hand side. If we try to consider each prime factor, we have 7 is congruent to 1 mod 3, meaning that no matter how many copies of 7 we choose, that product is going to be congruent to 1, because if we square it, we will just get 1 times 1, which is still equal to 1 mod 3, meaning that if we have 2 copies of 7s, which is equal to 49, the remainder is still equal to 1, which is not what we want. However, if we try to check 17, we get 17 is congruent to 2 mod 3. So, in fact, that also tells us that each factor must contain at least 1 copy of 17, so that we will satisfy the condition that each factor is congruent to 2 mod 3. So, in that case, what are the possible combinations? Well, we can have 17 to be our factor, and of course we can have 17 times 7, which is congruent to 2 times 1, which is just 2, so it works. And we could also have 17 times 7 squared, and again multiply with another 7 is still going to satisfy the condition that we need. Then what else can we have? Well, we have 17, but we can also multiply with 2 more copies. And again, if we try to square both sides of the congruent relation, we will get 17 squared is congruent to 2 squared, which is equal to 4 or congruent to 1 mod 3, meaning that 17 if we try to divide 17 squared by 3, we will still have the remainder equal to 1. So using this idea, we can just multiply with 2 more copies of it, giving us 3 copies. And this is going to satisfy the condition. Similarly, we can have 17 cubed times 1 copy of 7. And last but not least, we have 17 cubed times 2 copies of 7. And again, we can actually pair them up. So since the right hand side is equal to 7 squared times 17 to the 4th power, if we choose one of the factor be 7, then the other factor must be the remaining part, 17 cubed times 7 squared. If we choose the first factor be 17 times 7, then the other factor must be 17 cubed times 7. And if we choose the first factor be 17 times 7 squared, then the other factor must be 17 cubed. Very good. So we're almost done. So now we actually can find all the possible cases, which actually gives us 6 different values. And again, you will actually find that the last 3 pairs are actually similar to the first 3 pairs, except the A, B values are actually switched. Then we're going to write down all the possible values for A, and then you will be able to figure out what B is. So this is going to give us, for the first case, when the first factor 3A minus 2023 is equal to 17. So this is case 1. This is going to give us 3A is equal to 17 plus 2023. And by dividing both sides by 3, we will find out the value of A is 17 plus 2023 over 3. So we can use this to find out the rest of the cases. So case 2, we will actually get A is equal to, instead of 17, we have 17 times 7 plus 2023 all over 3. And so on and so forth, so that we will actually get all possible values and give us the solution sets. So solutions, we will have the first one, 17 times this, plus 2023 over 3. Then for the other one, we'll just match with down here, which is 17 cubed times 7 squared plus 2023 all over 3. And then we'll actually get all the possible pairs. And then I'll leave the last 3 for you guys. So the other 2 pairs will actually look like this. We have 17 times 7 plus 2023 all over 3, comma, 17 cubed times 7 plus 2023 over 3. And then for the third one, we will have another 7 here. And then we will take the 7 off from the B value, like this. And then for the remaining 3 pairs, we'll just switch the AB values from the first 3 pairs, and we'll be able to get all the solutions. All right, that's it. Pretty cool, huh? So I hope you all enjoyed this video. And if you want to find out more about other videos, you can go to my channel, and also you can subscribe it to find out other types of videos. And if you don't want to miss my new videos, you can also turn on the notification. Any thoughts or ideas, you can leave your comment below. I'll see you guys in the next video.